Hi everybody, in this video I am going to discuss full header design using two half header. This is very important question, full header using half header. First of all, we have to know what is half header. Half header is used to add two single bit binary number, and truth table is for there are two input A and B and two output sum and carry out. So two input mean there will be four combinations 0 0 0 1 0 1 0 0 1 1. For A and B, 0 plus 0 sum is 0, carry is 0. 0 plus 1 sum is 1, carry 0. 1 plus 0 sum is 1, carry 0. 1 plus 1 sum is 0, carries 1. So this is the truth table for the half adder. Now the circuit diagram for this truth table. We can easily create this circuit diagram without K-map. That is for sum S equal to this A bar B. We need to consider this only mean term. This means 0, 1, 2, 3. We need to consider 1 in second position. That's mean A bar B. We know 0 mean bar and 1 mean bar without bar. And A B bar. This is the expression for XOR gate A and B. And for C out, only third position there is a 1. That's mean A and B. C out equal to A into B. Now the circuit diagram is A and B. We need to consider two input A and B. Just there is an XOR gate, and A into B mean there is an AND gate. So this is the structure of. Now we need to construct the truth table for full header. Now the truth table for full header. Now we need to construct the truth table for full header. Now truth table for full header. We know the full header has three inputs: A, B, and C in, A, B, and C in, and two outputs, sum and carry out, C out. There will be 8 combinations of row, 1, 2, the 3 variable mean 2 to the power 3, 3, 4, 5, 6, 7, and 8. And decimal values for each row is 0, 1, 2, 3, 4, 5, 6, and 7. 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. So these are the easiest way to convert decimal to binary. Equivalent decimal equivalent binary of 3 is this 0, 1, 0. 4 is equivalent binary number for 3 is 0, 1, 1, 4 is 1, 0, 0, and so on. Now we need to construct the sum and carry out. 0 plus 0 equal to 0. 0 plus 0 equal to 0. And then next scene will be added. 0 plus 0 is 0. Means sum 0 carry 0. Sum 0, C out is 0. Next one is 0 plus 0 is sum 0. No, there is no carry. Then plus 1, I mean sum 1. There is no carry. Sum 1, C out is 0. The next one is 0, 1. 0 plus 1, sum is 1. There is no carry. Then next 0, 1, and there is no carry. Mean 1, 0. Next one 0, 1, 1. 0, 1, 1. 0 plus 1 is 1. There is no carry. Then 1 is added. 1 plus 1 is 0. Carry is 1. 0, 1. Next 1, 0, 0. 1 plus 0, sum is 1. There is no carry. The next 0 is added. 0 plus 1 is 1. There is no carry. Mean sum is 1, carry is 0. Next for 1, 0, 1. For 1, 0, sum is 1. There is no carry. Then for next one, sum is 0 and carry is forwarded. 0 plus 1 is 1. Mean this is 0 and this is 1. We can easily create this table. 1 plus 1 mean 0 and carry some 0 carry 1, and 0 plus 0 0 1 mean this is 0 and 1. Next 1 and 1, 1 plus 1 added together, 1 0, some 0 carry 1, then next one is added, some 1 carry 1 mean 1 and 1. So this is the truth table for full adder. Now we need to construct the Boolean expression. For finding Boolean expression, there is no need to use K-map. Just simply express the Boolean expression using the mean term. That is S equal to, there is a 1 in the second 1 position, and this mean for this one, A bar B bar C in. A bar B bar C in. Next one is for second position, is A bar B C in bar. A bar B C in bar. And this for fourth position, A B bar C in bar. A B bar C in bar. Next for seventh position, A B C in. A B C in. Now take A bar as common. That's when B bar C in plus B C in bar. B C in bar. Next one is take A as common. That's mean B bar C in bar and B C in. This is the Boolean expression for XOR gate. Mean A bar B XOR C in. This is the Boolean expression for XNOR gate. A B XNOR C in. Now we know that XNOR is a complement of XOR. That's mean A bar B XOR C in. Now this one is a complement of B XOR C in. Now we can write this. As a XOR operation between A, B XOR and C in. So this is the sum expression for full adder. Now we need to find the carry expression. That means C out equal to, here there is a third position, there is a mean term. Mean this one is for third position, 0 1 1 mean A bar B C in. And for fifth position, that's mean A B bar C in. For sixth position, A bar A B C in bar. And for seventh position, A B C in. Now we need to take there is an A bar, this is a C in common, taking C in as common. That's mean A bar B plus A B bar. Okay. Now here AB, take AB is common, C in bar plus C in. This is the XOR operation, means C in A XOR B, A XOR B. Now we know that A plus A bar equal to 1. That means Cn bar plus Cn equal to 1. And 1 into AB equal to again AB. This means AB. So this is the simplified version of C out. Now we need to create the full adder using half adder. These Boolean expressions are useful for creating full adder using half adder. First of all, we need to create the half adder circuit. This is A and B, E, A and B, an XOR operation between A and B. This is me A XOR B. And another for C out. This is the circuit diagram for half adder. This is AB. Now we need to consider another input, that is C in. Now this is AB and another is C in. And this one is known as C in and C in. Now performing XOR operation, we will get A plus B XOR plus C in. So this is the output for sum. Now we need to construct another AND gate for this half adder. This one is AND gate. The output of this AND gate is, this is A B XOR and multiplied into C in. in A, B XOR into C in. So this one is for C out, A C in into A plus B XOR, and we need to add A plus B C in plus AB, and these are added together, we'll get C out. There is an OR gate. This one is known as C out. So this is the full adder circuit, but here we are using two half adder. This one is a half adder 1 and this one is a half adder 2. So we can easily create full adder using two half adder, and there is an OR gate. So thank you very much for watching this video. Share and subscribe it. Thank you.